Welcome to this module on data architecture for data sharing as part of the AiMTT program. The learning objectives for this module is to have a deep dive on the data architecture used for SAIL 2025, to understand some of the benefits from this data architecture, and to look at some limitations and other relevant considerations for choosing a fitting data architecture. One of the most important things for working during SAIL to prepare the event was that there were very large number of organizations trying to work together and to share data. And those organizations were not just the event organizer, different types of government agencies, but also businesses trying to provide analytical services and other parties that were involved in the event, either to build up the area or other roles. And those roles were, you could characterize them as in different types when it comes to data sharing. We had data providers, we had data integrators. Those are the organizations that not so much create data, but rather make data connectable to other data. We had data analysts, people who were trying to make insights from the data that was available. We had data visualization experts, people who make those insights accessible to the end user by visualizing them. And of course, the end users themselves, who were trying to gain an understanding, make better decisions based on that information. And the data architecture needed to support these different roles and to make sure that all of these different stakeholders could do what they wanted to do. And there was a choice to use the Data Services Hub provided by KPN to share the data between different parties in a publish and subscribe model within a trusted network. And to understand why this was a logical technical choice, we take a look at the little image on the bottom of the slide, and we see that if we were to share information with all these different parties, and we were doing that with direct connections, like we see on the left-hand side, then we would require a lot of connections to be made in order to reach all the parties involved. So that from a technical perspective would be very difficult, and would be very a lot of work to create the connections and then to maintain them. If there was one organization that would receive everybody's information, and we would then transform that, then we could have had the middle picture. But in this case, there were multiple organizations who were providing analytical services. For example, the Technical University of Delft, Analyze, uCrowds, and some other parties as well, who were involved in creating analytical insights. So it was not one organization creating a view for everybody. There were multiple people using each other's data to create new data services. So that's why we ended up in the right-hand side of the picture, where we have a shared hub, a data distribution solution, where everybody works from a tenant. Everybody has their own node, part of the network, and everybody can bring data and receive data. And together, within that trusted network, we have a minimum number of connections. Those connections we can make very secure, and those connections can be low latency, meaning that there's little time between sending and receiving messages, allowing us to do real-time analysis and provide insights that are really fresh, actual live feeds that are being analyzed and processed. This gave a good approach for bringing multiple parties together, and the tenant structure and the hub and spoke model were a crucial part of this. When we're looking at the hub, the platform itself, there were multiple ways to get data on the platform, then to process it, and then to use that data for other purposes. And we will cover each of these topics separately during the next slides. Getting data on the platform, the ingress connectors, there were multiple possibilities. Sometimes there was batch data, or data that could be stored on an environment. This, for example, was done with predictions for weather data from the Dutch Weather Institute. Then they placed their output on a shared environment from which others could read the information and then use that data. But also connections with APIs were made, and they were published as streams on the DSH platform using either Python or FMA, which is a low-code ETL tool, which was also being used. And of course, other existing data streams could also be used by subscribing to them and then making some changes and publishing it as a new stream, for example, by adding some filtering or other adaptations or more complex adaptations, as we will see in a minute. And once we have the data on stream, then an organization can decide who gets access to that stream, and they are in full control of providing or not providing that data. So that gives us a good way to fill in data governance aspects on who owns the data and who can have access to the data. For the analytics, we have some on-stream analysis that was run live on the platform, doing computations and outputting new predictions, for example, also as a streaming service that could be then used by others. And during sale, we ran into some trouble running the artificial intelligence models, which had something to do with the capabilities that were being used. There were mainly CPUs being used. In retrospect, and this is something that we discussed after the event also with KPN, we should have used a GPU version of the platform, which was also available but was not provided as part of sponsoring. So this learning for us that to do the deep learning and other the types of AI modeling, we could have saved ourselves some trouble by running GPUs rather than CPUs, leading us to have some better performance. But all in all, many advanced analytics were possible already with the CPU. So many things did work, but it's always good to keep your eyes out for learnings for the next event. So then I would definitely recommend some GPU processing. Then getting data from the DSH into something else, for example, a viewer, a dashboard, or whatever you want to use to show it to your end users is also very important, because on stream in the DSH, it's just a data stream. It's not being visualized. It's not something that is consumable by your end customer, the people making this decisions, the crowd managers. So that still has to be done. And there were multiple systems that could do this, but Map Gallery was one of the most important ones. This was a digital twin environment with 2D and 3D maps. And in order to get the information in there, the data was transformed to conform also to the open GIS standards, and from that the web feature services, sometimes WebSockets or other services, were being used to make the data accessible for the viewer. And this allowed for real-time information to be processed on the map and in the digital twin common operational picture solutions. To conclude, there were many organizations involved in SAIL with different data roles and different degrees of technical skill. And in order to bring them all together, we chose a publish and subscribe model for cooperation based on the Data Services Hub, the DSH, provided by KPN. And this gave the benefits of a minimum number of technical connections to share data and to maintain. It gave us low latency, secure connections, and full access control for the data owner. And one of our learnings was to use the GPU workload for on-stream analytical services, such as complex AI. because CPU was sometimes too slow to support the advanced AI models. But otherwise, we were happy with the choice we made and had a lot of benefits from that, allowing us to have a lot of information products delivered in a very short time. Thank you for watching this module, and maybe see you on one of the other episodes.